So what happens is like basically now if we will try to see states gradient, so we need to find the gradient with respect to state. So here are some derivatives note you can take. Now first we need to find derivative of loss with respect to HT, because here we can see derivatives of loss. The first like hidden state is this thing, and it depends on OT and CT. So we need to find that first. YT is actually short for VHT. We can take this as Z, and so it changes to something like this, and loss is this one only, as you know, binary cross multiple loss. Now first we will find DL by DHT. That is nothing but DL by DYT, because the loss starts, back prop can start from Y side. This is a back propagation flow, and the forward propagation is something like this, that you might be aware in LSTM cells. What are the components will be there, all those. So back propagation start from here, so it's like a chain rule, and this is the independent variable on, and this is the independent, so it depends on this one, and vice versa. So if we try to calculate loss for this, we need to backpropagate this information, loss information, that means DL by DYT, we need to backpropagate to DL by DHT as chain rule, you know that. So now what we are doing is DL by DHT, if you want to calculate, we need to start from DYT hat, like YT hat means prediction variable. So here DL by DYT hat by DZT, ZT is nothing but this one. I think here we are shown, yeah, this one, this is the ZT. So and then DZT by DHT, because in the this is ZT, right? So and we have HT, and V is a constant. V is constant in the sense it's a weight, it's like a vector or matrix. So we can just like if you want to with respect to DHT we want to find, now we can say as a chain rule we get the same thing. And if you'll substitute all the results, these are the things, and the dimension also there, you can solve it, you can pretty much calculate it. Now we need to find, we have found with respect to HT, now we are actually calculating gradients for states, all the states. So states are hidden state, cell state. So now we are fine for hidden state, now we will try for cell state. Again we need to start from YT by HT, DYT by HT, YT by HT means we need to go HT by CT. So HT we have here dy by dht, because VHT now we are not taking as ZT because we need to go till CT, that's why. Earlier it was just for the HT, so we can take this as ZT, then ZT by CT, but here we should go to CT, so we can pretty much write like what we can say, dy by dht, then dht by dct. So that's the same thing, dy by dht, dht by ct. It's something similar to like dy by yt hat by dzt, then dzt by dht, then dht by dct. Yeah, we can prolong it as much as you can if you can substitute the same thing, because we are only giving the labels, so everything we are creating actually. So nothing peculiar thing happens if we do like this or this. This is again chain rule. So this is there, yeah. So we'll get this equation and dimensions are same, and this is header mode matrix multiplication, something like if we have something, these are the two matrix, 2 cross 3, 2 cross 3, again we get 2 cross 3, so it's like element wise you can like multiply like this, something like that. This is an example, you can figure it out, and I'm just using short form, something like this. For this dl by dgt, instead of writing big thing, we can just write dgt. So yeah, so here as I said, dl by dy, I is input gate, so we have ui weight over here and wi weight over here, and uf is nothing but forward gate, uf weight and wf weights are over here, and then output weight, and here u weight and w weight is over here. This u weights are for inputs and w weights are for the previous heuristic or previous output what we are getting to the cell. And then and again we are talking mainly about one cell, again for all cells are then again we need to backpropagate, and we have also seen backpropagation through time in RN, so that's the basic actually. So you can just use that as base here also, and UG and WG is over here in candidate gate, GT like UG and WG. So these weights are we need to calculate the derivative of loss with respect to these weights. We need to calculate so that we can substitute over here, so that we can perform gradient descent, so that our model can be trained perfectly to test on the new data also. Now we will find derivative of loss with respect to candidate state GT. The dimensions you can just is mentioned over here, you can just see that, And first we need to find with respect to yt hat prediction, then yt hat by ht, ht by ct, and then ct by gt. So I want to just show you like this: yt here with respect to first loss with respect to yt, then yt by ht, then ht by ct, then ct by gt. Then we can just, because we are just finding this till here, so we are just back out till here, and you can get substitute those values, derivative values, you will get this equation something like this, and the dimensions are this, and there's a head multiplication where I have mentioned like this, and this is a symbol which I used.